Okay, so the lab that we're doing, the experiment we're carrying out, we have a car that's rolling down the ramp, and we're collecting data for position, time, and velocity versus time. So we're taking the velocity versus time and we're plotting that so that we can calculate or determine an acceleration based on the slope of the graph. We want to take that experimental value for the acceleration and compare it to the ideal value for the acceleration of the car down the ramp. So the way we're going to do that is based on the height of the ramp, the length that the car travels down, and this angle right in here. Now, the angle is going to be sine theta equals opposite over hypotenuse, so height divided by length. Now, obviously, if we keep increasing the height, the acceleration of the car down the ramp will end up being equal to gravity when the ramp is held vertically. So what we want to do is we want to calculate what that acceleration is based on the different heights before it gets to 90 degrees. That calculation is going to be our ideal acceleration for the car at the different heights. Now, when the car is on the ramp, we know that gravity is straight down. Okay? And we know that based on the height of the ramp, we're going to have a certain acceleration parallel to the ramp or going down the ramp. Okay? So we have gravity straight down, and we have acceleration down the ramp. Okay? So we can call this G, call this A. Now, if we just focus on these two values that are acting on the car, these two accelerations, we have the acceleration due to gravity and the acceleration down the ramp. If we focus in on that, then we have this shape, basically. A, G. Okay, so I know that this part of the rectangle or triangle is also acceleration. This angle in here is equal to theta, which is the same as this angle. Now, you can do a proof with parallel lines and similar triangles, etc., but you can just take my word on it that the angle between gravity and the perpendicular on the ramp is theta. Okay, it's equal to what the angle of the incline is. So what we're looking at if we just focus on this triangle here, we've got gravity, acceleration, right triangle, theta in there. So if we write another sine theta equals, it'll be A over gravity. Okay, now previously we had the sine of the angle based on length dimensions was height divided by length. So we have two equations that are equal to the sine of theta. So we're going to use that information to solve for acceleration. Okay, so acceleration is equal to, if we take where we see the sine of theta here is equal to h over L, if we substitute that in up here, then what we would have is h over L is equal to A over gravity. Therefore, acceleration is equal to gravity times height divided by the length of the ramp. So this is the equation that we use to find the ideal acceleration.